In telecommunications and digital subscription services, the daily stream of usage data consists of millions of distinct data points, from phone calls to data streaming, all of which must be captured, priced, and billed. Processing this data at scale requires a specialized junction at the center of the architecture, SAP Convergent Invoicing, or CI. Within the consume-to-cash pipeline, SAP Convergent Invoicing is the critical integration point. It sits downstream from rating engines like SAP Convergent Charging, which feed priced results into CI. Simultaneously, CI sits upstream from the financial subledger, providing structured data for contract accounting. The fundamental unit of data arriving at CI from these rating engines is the billable item, or bit. A bit is the digital record of a specific transaction, such as a call detail record, a recurring subscription fee, or a one-off activation charge. These incoming items are stored in CI with statuses like raw or billable, depending on data integrity and the success of the initial upload. Once loaded, these BITs reach the billing process, where CI must convert millions of individual, unprocessed items into actionable financial records. The core architectural premise is that the functional business logic of billing is identical, whether processing a single account or several million. The distinction lies in the execution architecture, the choice between single billing in dialog mode or mass billing through parallelized execution. System architects must master both paths to maintain the granular precision needed for manual exceptions while ensuring the high-volume throughput required to prevent database locks. To understand these architectures, we first have to isolate the functional transformation a BIT undergoes, regardless of how it is executed. In SAP terminology, this workflow splits into two distinct steps. We focus on step 1, billing, on the left. The transformation begins with selection. Logic evaluates bits against business rules, filtering out items not yet due or failing to meet current selection criteria. Valid items move to the second phase, grouping. The system groups the items based on shared master data, primarily the contract account and the currency. These groups then move into the final phase, aggregation. Aggregation condenses the grouped items to minimize the total number of records before they reach the subledger. This process results in the billing document, which acts as the standardized output for the next stage. This sequence, selection, grouping, and aggregation, is a fixed functional requirement of the billing framework. Whether resolving one customer dispute or processing 5 million records in a nightly batch, this exact mathematical transformation must occur. The challenge for the architect is scaling that fixed logic to fit within a limited overnight processing window. SAP provides two execution paths to handle different operational scenarios. Dialog mode, accessed through transaction fkkbix.s, is a synchronous tool for manual processing. It targets a single business partner or contract account at a time. This is used for diagnostic tasks like resolving customer disputes, handling system exceptions, or validating new configuration changes. Dialog mode includes a simulation feature, which allows a consultant to preview the billing output without committing any data to the database. It also offers an expert mode, giving operators the ability to manually override grouping characteristics or invoicing units to test specific edge cases. For production environments, we use mass billing via transaction fkkbix.ma. This is the automated engine used for scheduled daily or monthly production runs. Processing millions of items in a single thread would create severe database locking as the system attempts to update thousands of records simultaneously. To solve this, the system uses parallelization to partition the workload. The primary parameter for this parallel processing is the contract account. By routing all bits for a single contract account to the same processing thread, the system maintains data integrity and eliminates the risk of conflicting locks. Mass billing also includes runtime restrictions as a critical failsafe. If a job exceeds its specified time limit, the system cleanly commits the accounts it has already finished and leaves the remainder in the queue for the next scheduled run. The difference is clear. Dialog mode is designed for granular diagnostics and human intervention, while mass billing is designed for stability and high-volume throughput. Despite these different execution paths, the functional outcome is the same. Whether generated by a manual click in fkkbikbis or an automated job in fkkbikbima, the system produces a standardized billing document. The creation of this document signifies the completion of the billing step. This stages the data for the next phase, Step 2, Invoicing. In this next stage, these billing documents will undergo further selection and aggregation before being posted to accounts and formatted for printing. Moving into Step 2, Convergent Invoicing will use this same dual execution architecture to manage both individual invoices and mass runs. Navigating these systems requires recognizing that while business rules are rigid, the execution architecture must remain flexible. Success in SAP Convergent Invoicing depends on balancing that fixed logic against the operational requirements of both scale and precision.